Welcome to a place where urban mobility is possibly as chaotic as anywhere and probably dirtier.
The Indonesian capital is one of the fastest growing cities in the world. Its population of 8 million people is expected to double in 15 years. There's no urban rail network here, so mass transportation depends on buses, the major contributors to the nightmare of noise and carbon monoxide. But Indonesia is about to capitalise on a new transport system, and remarkably, it's based on an idea that's 150 years old.
Aeromovel is a Brazilian brainchild made to work commercially for the first time by a small Indonesian engineering company on the outskirts of Jakarta, with the help of an American advisor.
It's been done in 8 months, not 5 years. It's been done for $9 million, not $80 or $90 million as maybe happened in Miami.
First appearances suggest this could be similar to many other elevated transit systems, but get on board and the story changes.
The difference between this light rail system and others is that with this, we're being literally driven by air.
We're developing a new technology, something like a steam engine versus a horse, or the electric tram versus the steam engine.
The principle of using air to move large numbers of people goes back to the days of steam, when in England the South Devon railway line was built in the 1840s. It didn't succeed. In the 1990s, Aeromovel has considerably more chance of success. The guideway carries the propulsion system in its belly, so to speak. Low-pressure air generated by electric blowers placed under the track. The vehicles move along standard rail lines, used because steel wheels have 1/10 the resistance of rubber. They can be either pushed or pulled by the air, which is kept in the 1 metre square duct by self-sealing rubber strips. And replacing the drive motors on the vehicle are rigid struts, each attached to the undercarriage at one end and square steel plates inside the duct at the other.
The flow of air through the duct is controlled by a series of separation valves, so when they're down, there's nothing to stop the air coming through, and that presses against the propulsion plates attached to the chassis of the carriage.
Each car has 2 of these sails, and under the guideway, atmosphere valves open when the air is needed to be pushed out in front of the car, and closed when it's being pushed from behind or sucked forward. Because there's no motors and transmissions on the carriages, they're lighter. Therefore, the concrete support structure and track bed can also be lighter and more flexible. The articulated carriages have the ability to handle tight curves and even go up or down gradients not normally considered feasible with other systems. Prefabricated off-site, the concrete pylons and rail beds were lifted into place and put together manually. For environmental reasons, not a tree could be cut nor a building moved. Just some of the design headaches for these 2 men, given the task of proving an untried and unusual mass transporter for a country unable to subsidise its construction or operation. Compared with the installation of other elevated systems, this one is so simple, yet so clever.
And the operating cost is about 25% of what we're finding today with automatic people movers.
There's no need for drivers in each vehicle, as the entire circuit can be controlled by just one operator, who can do it manually or sit back for pre-programmed automatic running. Magnetic switches placed on the track every 25 metres indicate where the carriages are at all times. Digital indicators show the speed of vehicles in each route section, and because the valves in the air duct separate one route section from another, they enter a section only when the vehicle ahead has moved out of it.
We're travelling at about 50 kilometres an hour around a 3.2 kilometre circuit, 5.5 metres above the ground, over the top of President Suharto's pet project, the Taman Mini theme park.
The 500-hectare theme park was an ideal venue to prove the adaptability of Aeromovel. The proof of the Indonesian pudding is in Aeromovel's ability to move 12 to 15,000 people an hour with an energy consumption of just 65 watts per passenger. It takes just 500 kilowatts to run the Taman Mini circuit. And though it operates only on weekends and public holidays, with a fare structure to suit the Indonesian pocket, it does so at a profit.
This seems the least likely of places to find a new development in transit systems. But a small group of engineers has proved its ability to move large numbers of people cheaply and efficiently. Now, there is a real possibility that Aeromovel will have a big impact on other cities around the world.